702.
702 for the curious.
On 92.7 and 106 FM.
Today, we're starting off with a debate that seems to be going on around the ethical line being crossed by scientists who've been doing brain work or research on the brain. And in some cases, it's believed that some scientists have transplanted the tissue that they've grown in the lab into animals. And so debates about ethics have raged. You've taken a look at this. What does it mean? Or what have these scientists, these neuroscientists, been up to?
This relates to the creation of what are called organoids. These are not just things which are parts of the brain. You can make organoids, which are mini organs, from any body part now, as far as we can tell. Now, the rationale for doing this is that you can take a small part of the body, you can get some stem cells from that area, and using the right cues or stimuli or growth factors in a dish, you can coax these stem cells to recapitulate the mature organ that they come from, albeit on a miniature scale. This is really important because it's a way of producing tissue that we can test out drugs on very reproducibly. And there was a lovely story which we covered about a week ago where scientists actually were making organoids like this from a patient's cancer. And by making cancer organoids, you could test out chemotherapy on them, and you could tell whether or not the person's cancer would respond to that chemotherapy without giving the drugs to the patient and them finding out the hard way by suffering all the side effects. Equally, there are some disorders which are caused by you inherit a certain gene from your parents, which makes certain parts of your body work a certain way. And sometimes those genes can make certain body parts go wrong in a certain way. We know, for example, that schizophrenia, depression, bipolar disorder, many of these major psychotic illnesses have a really strong familial trait. And about 1% of the population suffer with them. So they're also really common. And if you have a first degree relative who has one of these disorders, you're much more likely to get them. So rather than try to do studies on people, and that takes a very long time and can have ethical problems, what scientists are also saying is, well, if we take some stem cells from a person and we produce some brain cells in a dish, maybe we can understand what's different in these person's brain cells compared to other brain cells that increases their risk of developing one of these disorders, and therefore we have a chance of intervening at an early stage to try to reduce that risk. So it's all based on very sound principles of understanding actually the mechanisms of disease, the mechanisms of development, and the ways in which we can produce new tissue to fix things. Now, where the current ethical debate comes and stems from is that there are people making brain organoids. In other words, you take stem cells, you coax them into turning into brain cells, and then they wire themselves together. And these are tiny. I mean, let's not beat about the bush. These things are literally a tiny pinhead blob's worth of cells, a tiny little blob in a dish. This is not something on the scale of a human brain, which weighs 1.25 kilos. But at the same time, they do begin to demonstrate electrical activity in the same sorts of patterns of electrical activity that a mature human brain does. And so what scientists are saying is there needs to be some kind of policy in place, or there should be a conversation being had about at what stage do we begin to worry that as we make these things more and more complicated, that they could become conscious. And if they became conscious, would we be subjecting these blobs of cells in the dish to the ability to feel intolerable pain? And when we're doing experiments on them and things, we could be subjecting our mini brains in dishes to horrible, painful stimulation and not realizing it.
Good afternoon, Peggy. The Naked Scientist is with us. What's your question?
Yes, my question is, as modern day human beings, we eat a lot of food that is preserved, food that is canned, cool drinks that contain a lot of preservatives. Firstly, the first question is, does the human body absorb these preservatives? And secondly, does it mean now when we die, when a modern day human being dies, does the body take longer to decompose than it happened at a time when fewer preservatives were used in food?
In food, wow. Interesting question. Chris?
I did see someone with a birthday card once, and it said, you've reached the age of nearly 100, which just goes to prove that alcohol is an excellent preservative. Have another drink on me. Um, you're quite right that we do use a lot more chemicals in our foodstuffs in order to make them have a longer shelf life, but that doesn't necessarily mean that they're artificial or bad for us. Vitamin C is actually a really good preservative because it's an antioxidant. And by putting these things into the food stuff, you can soak up some of the molecules that would cause the food to degrade and make them last longer. So we must be careful not to tar everything with the same brush. Just because it's a preservative or it's an antioxidant, it doesn't mean it's necessarily going to be bad. There are certain classes of chemicals, though, that do build up in the body. And a really good example of this are things like what we call persistent organic pollutants, POPs. And people have been doing studies on how these build up in the environment, because when you go and buy a packet, for instance, some burger chains and things will serve your fries in one of those cardboard sachets, but the cardboard is very shiny. We all know what I'm talking about. And they put the chips in there, and the reason they coat the cardboard with that is that then it doesn't soak up all the grease out of your chips and become unpleasant. The problem is that the coating that's applied to that is a very stable perfluorinated hydrocarbon, and because it's a completely unnatural molecule, there's no metabolic pathway in the body to break this down. And there's virtually no metabolic pathways in the environment that can attack this molecule because it's unnatural. Wow. Nature's never seen it, never had time to evolve to do anything about it. These chemicals leach into the environment in tiny amounts. They go into our bodies in tiny amounts, and they slowly accumulate up the food chain. And now there are deposits of these things in Antarctica because penguins have been catching a lot of fish. And the penguins then accumulate these things in the fish. And when the penguin dies, its body, which has got a high dose of these things and other chemicals, is then left to rot on the ice. And these chemicals are there, and you can actually detect this. So it's certainly true that some things which are intended to preserve do build up in the environment. And we have to be very cautious. And people are now beginning to think very carefully about this and the whole life cycle analysis of what we do and what we use, thinking about, rather than just making something, how we end its life as well. And we're trying to engineer into the cycle a plan for when this thing no longer has a use, how will we make sure we safeguard the environment? And part and parcel of that is safeguarding our own bodies. So we're not rotting down any more slowly because we're eating a diet replete in preservatives. And let's be clear, preserving food is good, because if you eat bad food, that's not good for you either. But at the same time, we need to have good environmental stewardship.
Absolutely. Oh, what a great question, Beggy. Thank you for that. Hello, Simon.
Hello, ma'am. How are you?
Good, and you?
Hello. When late at night, around 3 o'clock, 4 o'clock mostly, when there's a shooting star, what will be happening in the sky by then? Like that star that's moving around, what will be happening in the universe by then?
Okay, for that to happen, what is a shooting star? Thank you, Simon.
Yeah, hi, Simon. Well, although we call it a shooting star, we only call it that because it looks like a star that we see in the night sky as a bright light source. Now, the stars that you can see are chiefly stars in our Milky Way galaxy, and there's about a couple of 100 billion stars in the Milky Way galaxy. Those are entities a bit like our sun. The Milky Way is 100,000 light years across. So that light has come up to 100,000 light years to see you. So those stars are a long, long, long way away. So they look tiny. The objects that you see in the sky look the same size as them because they're much closer to us, but they are themselves tiny. They're small objects that have come in from space. They're coming in at very high speed. They may be doing tens of thousands of kilometers an hour as they race into the Earth's atmosphere, accelerated by the Earth's gravity. As they race down through the Earth's atmosphere, they're pushing down on the gas of the Earth's atmosphere. And when you compress a gas, you make it hot. This is how an engine works. If you have a diesel engine in your car, you're compressing gas. You're doing work against the gas. If you're doing work, you're burning off energy. So you're giving the gas energy. If you give something energy, its temperature goes up. So as these impactors come in through the atmosphere, they squeeze the atmosphere. This drives up the temperature of the atmosphere, and it makes the gas around the object glow, and it also burns off a bit of the surface of the object. And as a result, that can add to the coloration as well. So a shooting star is a small object, a micrometeor, or in some cases a meteor, bigger object. Sometimes they can be the size of a house, but very, very rare. Most of them, they're just small particles coming in at very high speed, very high velocity, and they're compressing the gas of the atmosphere and making it glow. And that's your shooting star.
Amazing.
You tend to see them at night because
Amazing.
obviously they're coming in all the time, but you see them at night because relative to the sky, they're much brighter, and so they stand out.
Yes. So is space debris, can we also mistake that for shooting stars? How does it, if it does come out of orbit, look?
Oh yes, and if you see an object coming in from space because it's fallen out of orbit, for instance, bits of dead satellite and so on, they too will become very hot as they come in. Most people were watching the 50th anniversary of the moon landings recently, and they'll have seen those wonderful recordings of the capsules coming down and so on as they were recovered back into the sea. And those things themselves also get incredibly hot for precisely the same reason, that you've got something traveling at high speed, it's doing work against the Earth's atmosphere, squeezing it, and that drives up the temperature of the Earth's atmosphere, makes the atmosphere glow, and makes the underside of the object glow. And as a result, it gives out light that we can see.
My guest, of course, is Chris Smith, the Naked Scientist, and we're taking your science-related questions. And we go to Lerato calling us from Germiston.
I just want to ask one question. What is it about cancer that really there's no cure for? People can spend money on it on the hope that a family member, whoever, will survive. What is it about cancer that there is no cure? Yes, they can say chemotherapy and all that.
Yeah.
But there's only one way, irrespective of money that's been spent. How come medicine has not found a total cure for cancer? Please.
Great question, Lerato. Thank you very much. Your thoughts, Chris?
Well, first of all, I'm sorry if you've been touched by this, but the reality is that the risk for all of us coming into contact with cancer is about 100%, because one person in two will in their lifetime develop cancer, which means that you will know someone or you yourself will have a brush with this disease. It's a genetic disease, and this occurs because as we get older, there are 37 trillion cells in the average human. Each of those cells, with the exception of your red blood cells, has a complete copy of your DNA recipe book, and written into that DNA are the messages for repairing DNA. And this keeps your DNA intact and working well throughout most of your life. But as you age, you encounter various chemicals and other stimuli that can damage your DNA. And if you damage the genes that repair your DNA, eventually you get to a point where you can no longer repair your DNA efficiently, and then your DNA begins to accumulate more and more and more damage very quickly. And if you damage the genes that control how cells grow, when they grow, and where they grow, then you can lose control of all of those things. And you can then begin to get cells that grow out of control, and they don't obey the normal rules that dictate where they can go and how they can grow in the body. And that's what cancer is. Now, the reality with cancer is that it actually takes a really long time to develop. Most people, when they get cancer, have actually had cancer for close to 20 years in some cases. But it's slowly accumulated more changes to the DNA. These are called mutations, which progressively endow the cancer and weaponize the cancer with the ability to be nastier. So actually, this is not something which we're all of a sudden developing and then dying from. We probably are developing this disease for a really long time. The other point to bear in mind is that cancer cells are human cells, and all of the body's defenses are actually geared up towards getting rid of cells that are not part of us, getting rid of microorganisms like fungi or bacteria, or dealing with viruses. So cancer has a head start because our immune system is programmed not to attack our own bodies. So until the cancer becomes really grossly abnormal compared to us, the immune system leaves it alone. And cancer cells also secrete various factors that turn off the immune system, so that you actually find it very hard to attack a cancer with your immune system. So all of these things come into play and make this disease very hard to tackle, because the treatments that we're coming up with find it very hard to distinguish between a cancer cell and a healthy human cell. The immune system struggles to do this as well. And by the time we know that a person's got cancer, often it's already been there for so long that it's spread around the body and involves so many different systems that the body is weakened and compromised. And this adds a further disadvantage to our efforts to try to help people. But the good news is that we're getting better at doing this all the time. And there are many cancers now that are curable, and there are many people who are cured of cancer. And that number is increasing all the time as therapies, strategies, and also our understanding of how the disease occurs gets better, so we can make bespoke therapies that have fewer side effects and are really, really good at dealing with cancer. But the long run, really, we're probably not looking at curing cancer. In the long run, what we'll do is turn cancer into a chronic illness, which, as long as you keep taking the pills, just like with high blood pressure, you take the pills and your blood pressure is normal, you might have cancer, but it would remain under control and suppressed, and therefore it wouldn't be a problem for you. And I think that's really where we're going with this in the long run.
I see. So let's not pin our hopes on a cure. What an explanation. My goodness, you could actually visualize it in your mind's eyes. You listened in to The Naked Scientist. Lulama, you're calling us from Winchester Hills. Tell us about your daughter.
Hi, Chris and Azania. Why is it that my daughter, when she uses her mobile phone in the car, she gets motion sickness? So she'll get nausea, like if she's on her, like WhatsApping or watching videos, she gets a headache and then she gets nausea to a point where, she can't even use the phone when the car is moving.
Okay, and is this at any position in the car, any seat, back, front? Everywhere.
Doesn't matter so long as the car is moving, and it's been happening since she's been using the phone. I mean, she's 13 now.
Okay. Chris, motion sickness and not watching the road, but rather watching the phone.
Yeah, it doesn't matter whether it's a phone or a book or a comic, magazine, anything that you do which is fixed inside the car is likely to increase the sensation of motion sickness. Looking out of the window and keeping your eyes fixed firmly on an unmoving, immobile point in the distance does not produce these symptoms, which is why the driver who's staring at things in the distance doesn't tend to get ill and sick, but the passengers, if they look at books and maps and things, they can feel more sick. Also, the driver who's in control of the car knows when they're going to be accelerating and decelerating the car and where they're going to steer to. So the body anticipates those movements, and so you can predict how your body is going to respond. And so that too also reduces the likelihood of nausea. Whereas when you have no control of the car and you're staring at something inside the car, which is moving around the same way you are, it stimulates your vestibular system, which is the balance organ in the inner ear on both sides of your head. And we don't understand exactly why, but when your eyes are saying one thing's happening, your balance system says another thing is happening, your body's logical conclusion is, I must be being poisoned by something and I'm going to throw up. We don't know why this happens. It just does. And the way in which we can control this is there are drugs. They include antihistamine drugs because there are histamine receptors, and histamine is used as a signal in part of the balance system. And there are also dopamine receptors and receptors for another neurotransmitter called serotonin, which are all involved in this. And there are various anti-sickness chemicals that can be taken. Antihistamines have the fewest side effects and are probably the nicest ones to take, and they tend to be pretty effective in most people. So if she gets this a lot, A, try looking out of the window, not looking at a phone, and that's probably good advice anyway. And B, you could try some things like the Stemetil or these antihistamines, which can be very useful and very effective in some people.
Yes. Oh, thank you for your answer, Chris. Lulama, I hope that helps. She must keep her eyes on the road. That's what you tell her. And be part of the conversation and what's happening in her surroundings.
Okay, thank you. Thank you, guys.
Thank you, Lulama in Winchester Hills. That's all we could get to today, Chris. And so sad that we couldn't get to all the calls that are holding. But we do this every Monday, so there's always an opportunity to chat to the Naked Scientist. Thank you as always.
Thank you very much. Have a lovely day, everybody. See you soon.